Why does a moving object keep moving while a resting object stays at rest? Newton's first law explains this mystery. What actually makes an object change its state of motion? The answer is closely connected with force and inertia. Sir Isaac Newton developed three fundamental laws that completely changed our understanding of motion and forces. Newton's three laws describe how forces affect objects, and the first law introduces one of physics' most important ideas. Today, we will deeply understand Newton's first law and discover why it is also called the law of inertia. Newton's first law states that an object remains at rest or in uniform motion unless acted upon by an external unbalanced force. This statement contains three key ideas: rest, uniform motion, and a force capable of changing that state. If an object is at rest, it tends to remain at rest unless an unbalanced external force acts on it. A football lying on the ground will remain there until a force, such as a kick, changes its state of rest. Now consider a moving object. It tends to continue moving with constant velocity when no unbalanced external force changes its motion. Uniform motion means constant velocity. The object keeps the same speed and travels in the same direction. In an ideal situation with no unbalanced force, a moving object would continue along a straight path indefinitely. But everyday objects often stop because forces such as friction act against their motion. It's against their motion. Here is an important point. Force is not required to maintain motion. Force is required to change motion. An object's state of motion means whether it is at rest or moving with a particular velocity. Particular velocity. A force can change an object's speed, its direction, or both, therefore changing its state of motion. The tendency of an object to resist any change in its state of motion is called inertia. In simple words, inertia is an object's resistance to changes in its motion or state of rest. Inertia depends on mass. Generally, greater mass means greater inertia and stronger resistance to changes in motion. Inertia is commonly discussed in three forms: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest is the tendency of a stationary object to remain stationary unless an external force changes its state. When a bus suddenly starts moving, passengers tend to lean backward. Their bodies resist the change from rest. The bus moves forward suddenly, but the passengers' bodies tend to maintain their previous state of rest. When a carpet is beaten, dust particles tend to remain at rest, while the carpet moves suddenly beneath them. The carpet changes its motion quickly, but the dust resists that change because of its inertia of rest. This is why it stays behind. Place a coin on a card above a glass. Quickly flick the card sideways, and the coin tends to remain where it was. Watch this experiment. After the card moves away, gravity pulls the coin downward into the glass. This demonstrates inertia of rest. Inertia of motion is the tendency of a moving object to continue moving unless an external force changes its motion. When a moving bus suddenly stops, passengers tend to move forward because their bodies were already in motion. Seatbelts are important because they help restrain passengers when a vehicle suddenly changes its motion.
The vehicle stops because of braking, but the passenger's body tends to continue moving forward due to inertia.
A running person cannot stop instantly because the body tends to continue moving in its original direction. The body's running person its original direction. After a football is kicked, it continues moving for some time because of inertia of motion. The football eventually slows. Friction provides an external force opposite to its motion. In space, where resistance can be extremely small, a moving object can continue traveling for a very long time. So remember, continuous motion itself does not require continuous force. An unbalanced force is needed to change that motion. Inertia of direction is the tendency of a moving object to resist any change in its direction of motion. Inertia: when a car turns suddenly, passengers tend to lean sideways. Passengers to lean sideways because their bodies resist the change in direction.
The car changes direction, but the passenger's body tends to continue along its previous direction.
Even when speed remains constant in circular motion, the direction keeps changing, meaning a force is required. A circularly moving object constantly changes direction, so an inward force is needed to keep it on the circular path. The circular path. When a bicycle turns, its direction changes, forces act, and forces act to make that change possible. Water droplets leaving a rotating object tend to travel along their original direction. This is because of inertia of direction. Mud can fly away from rotating tires because the particles tend to continue along their existing direction of motion. Thus, inertia of rest resists starting motion. Inertia of motion resists stopping. And inertia of direction resists turning. The amount of inertia depends on mass. A more massive object generally offers greater resistance to a change in motion. External force provides the necessary interaction that changes an object's existing state of rest or motion. When forces are balanced, the net force is zero, so there is no acceleration, and the state of motion remains unchanged. When forces become unbalanced, the net force is non-zero, causing the object's velocity to change. Net force is the overall effect of all forces acting on an object, and it determines whether motion changes. A common misconception is that force is always required for motion. Actually, force is required to change velocity. Exam question: if the net force on a moving object is zero, its velocity remains constant rather than automatically becoming zero. A stationary object can also have forces acting on it, as long as those forces balance and produce zero net force. The book remains at rest because gravity, and the table's normal reaction balance each other. Newton's first law tells us that objects resist changes, while an unbalanced external force changes their state of motion. Inertia is resistance to change, and greater mass generally means greater inertia. Let us summarize. Remember the three types: inertia of rest, inertia of motion, and inertia of direction. Quiz time! These ideas appear everywhere, from buses and seatbelts to footballs, rotating wheels, carpets, and simple classroom experiments. Newton's first law describes unchanged motion. Inertia explains resistance to change, and external unbalanced force produces that change. Now you understand Newton's first law and the law of inertia. Keep exploring physics because every motion tells a story.